Alright, so I wanted to give you a example of this. So creating my table, and we'll create this every single time for these types of problems. So I've got my big box for time, and that splits. Remember, there's different accelerations. So gravity is negative 9.81 in the y direction, right? It does not act in the horizontal direction. So therefore, I get a change in velocity in the y, but a constant velocity in the x direction. So it kind of creates this separation of equations, separation of directions. So, looking at the sample problem, kick a ball horizontally off a cliff that is 100 meters high at an initial speed of 20 meters per second. How far away from the cliff does it land? All right. So let's identify what variables they gave me, what variable I'm looking for. So nicely in this drawing, I gave you that Vx equals 20, right? It's kicked horizontally at 20 meters per second. So that's going to be here, 20 meters per second. And I guess I could put meters per second squared there. All right, just most everything should be in the base units, so we won't have to worry about that dimensional analysis unit conversion. They also told me that the height was 100 meters. I know that cut off here, 100 meters. So where does that go? X direction or Y direction? Okay, it's Y direction, right? It's vertical, and if I'm starting at the top of the cliff and going down to the ground, it's going to be a negative 100 meter displacement. Remembering that from our homework. So, right, gravity's negative going down, our displacement will be negative going down, and since we're kicked horizontally, everything on this worksheet is going to have this 0 in our initial velocity for the y, right? Because it's horizontal. Later next week, we're going to worry about changing this to be at an angle where it has both x and y components now. But that's later. Let's focus on getting used to equations in 2D. So that's what they gave us. And they're asking how far away from the cliff does it land. So they're not asking the speed that it lands. They're not asking this final velocity. They're not asking how long is it in the air. They're asking how far away does it land from the cliff. What is our range? What is our delta x? All right. Now, in order to solve for that delta x in the x direction, delta x equals vxt, I need to know our time, right? But how do I solve for time? I can use my y direction, where I have 1, 2, 3 things. Awesome. All right, so when I'm given 3, I can solve for the other 2. I could solve for final velocity if I wanted, but I'm going to go straight into solving for time with the equation that doesn't involve final velocity. So delta y equals v initial y times delta t. I could put y, but remember, they're the same. Okay, we did that with the red and yellow side-by-side screenshot. Plus 1/2 ay delta t squared. All right, so I plug in my numbers now. Negative 100 equals 0 plus 1/2. There's that negative 9.81, so they're in the same direction. That's nice. And delta t squared. Negative 100 equals negative 4.905 t squared. I divide by 4.905. I get 20.3874 equals t squared. I don't have to write down all that much because my calculator saves it. I take the square root of the answer. I get 4.515 seconds equals t. All right. So with the sig figs, it's 1 sig fig. I could round this up to 5, but that's a big error, right? So I'm going to keep that 4.515. All right. That carries into my x, right? So my y dimension determined how much time it's in the air. My now I can tell in the x direction how much time do I have to move horizontally at 20 meters per second. 20 times 4.515. And the range is going to be 90.305 meters. With 1 sig fig, that's 90 meters. All right. And again, if you wanted to solve for your final velocity, you could. I think that might be something that we look at later in here. Right here, you're looking at the initial velocity of the throw based on, they gave you different criteria. As we get into the next couple problems, I did include the answers here to help, so you can double check your work. What assumptions are we making? I discussed that, but yeah, 1, 2, 3, 4, 5. Oops, sorry for that page break. 6 questions. All right, so a good bit of practice here between now and Tuesday. I think you're ready to apply this, especially with kind of this framework. But yeah, this red box, as I box it in blue, this red framework is going to be the same for every problem. Because we're on Earth, gravity is going to be here. It acts downwards, so there's 0x component. And then for this section, we're launching horizontally, so that's going to be 0. Right? And then depending on what they tell you, they could give you time, they could give you height, they could give you range to change up how you're going to apply this. All right? So best of luck, enjoy, and I will see you on Tuesday at 5 p.m.